Hello everybody, my name is Hugo Lopez. Today I'm bringing you a contribution to the International Conference of Integrated Formal Methods, which has per title Chain of Events, Modular Process Models for the Law. This is a contribution with my co-authors Laurent Dubois, Thijs Latz, Amin Andalusi, and Thomas Hildebrand from the University of Copenhagen, TTU, IT University of Copenhagen, and TCR Solutions. In traditional approaches, implementations are given by code and architectural diagrams, but we don't really know how do they abide to the law. Normally, law is implemented in an after-the-fact fashion, which is difficult to translate later on. It also has a problem that since it is implemented after the fact, we need to make corrections to already existing systems with an overhead in cost and development time. The idea is to bring compliance by design, which means to start from the law and then generate implementations that are formally verifiable, but also easy for understand by legislators and other people that do not have a formal methods background. We've been exploring these approaches in different projects, the postdoc grant and hybrid business process management technologies, the Econo Grant Solutions project, and some Horizon 2020 projects such as Be Happy and GDHRNet. This project is inspired by current digitalization efforts in legislations. The idea is to cut the red tape, decreasing the bureaucratic processes that only delay the decision making in different municipalities. This requires that we first learn how to be more effective in the creation of laws, but also to be able to implement these legislations in a transparent manner. In the paper today, we're going to see how some of the elements in the law can be translated into a formal process specification. In this case, a specification given in a formalism called DCR graphs. Moreover, we not only want to express specifications alone, because laws are not given alone. Laws instead are given in relation to each other. This could be different paragraphs or different laws. So the challenge for us is to be able to decompose those into models, in this case different paragraphs of different processes, and to preserve the semantics that these relations have. Today we're going to explore these relations based on an extension called linked process networks, in which one process represents a law, and then the relations between these are communication between different process models. We're going to illustrate this into the formalization of the Danish Act of Social Services, which is currently used by the municipality of Sutjers in their case management applications. The development today is going to be based on the dynamic condition response graphs. Dynamic condition response, or DCR graphs, is a graphical model for the expression of regular and omega regular properties. This, in practice, is used as a business process management language, where domain specialists, in this case caseworkers, can express business processes in a declarative manner. So instead of describing the flows, they describe the constraints that different activities have to abide. Such a development is backed by not only a theoretical development, but also by adoption by industry and municipal governments in Denmark, especially. We've been working with the municipality of Sutjers in the northern part of Denmark, where they have a project based on the digitalization of the Consideration Act on Social Services. In particular, what the municipality wants to do is to be always abiding the latest legislation and minimize the cost and the gaps between the legislation and the implementation. What we've been working with them is on a solution where they can use the law as an input. So they can, domain specialist, in this case, a caseworker, can mark some of the events that different cases have to abide, and then the constraints between these events. This, in principle, is translated into a process model that can be validated and verified against a domain specialist, and then generates an implementation that is based on the formal language we developed. Let us briefly recap what time DCR graphs is with a little example from the granting of pension benefits from a municipality in Denmark. In this case, we have 6 events, a limited set of events, out of which are related by different set of conditions for different set of relations. In this case, a condition relation grants rights to other events to be executed. So just reading the first condition, it would say that once the citizen has reached a pension age, then the municipality may grant a public execution. Moreover, there's also response relations that impose obligations for events to happen. In this case, if the municipality has reached the pension age, then the municipality must grant public pension. Moreover, these events can be dynamically included or excluded at point. Time DCR graphs also has a notion of state. In this case, each event can be executed or not executed in this case, pending, so it is an obligation that needs to be fulfilled at some point, or included and excluded. Finally, an event is enabled if it's first it's included, also it's included. Its preceding events are either executed or excluded from the discourse. Given that this is that we are still in a time setting, then it's not only enough that it has to be executed on in a given time. We also need to respect the time delays. In this case, the municipality cannot grant public pension until 2 years have passed after having received the Danish citizenship. So once these 2 years have passed, then our event for granting public pension is allowed to be executed. After this brief recap, let us see how the modeling of real laws look like. The following example shows the structure of a very common law, in this case the European General Data Protection Regulation. As you see, each of the nodes here describe one of the articles, but what you also see is that all these articles, they are not really in isolation. They all require each other. Let us explore a little bit more the nature of the relations between legal paragraphs. And for doing this, let's go back to the Consolidation Act of Social Services in Denmark. What we see here in this paragraph is the description of a very common decision-making process in a law. In this case, the decision we need to take into consideration is not done in isolation. Instead, this decision requires to take into consideration different paragraphs or activities in these paragraphs. One of those paragraphs is paragraph 63. In this paragraph 63, we have a clear description on what the nature of the decision should look like with respect to the case. This decision influenced paragraph 48, and while we would like to have an overall understanding of the law in composition, for modeling, it is simpler for us to decompose the law into different paragraphs that allows us to modify and change and verify in isolation instead of in composition. So our solution is to propose that each of these paragraphs represents a DCR graph, is represented by a DCR graph, and that we allow a programming language construct to permit the synchronization between these different events. In this paper, we present the notion of distributed process networks. A distributed process network is a generic mechanism for synchronization of process models. This means that, and at the same time that we have a DCR graph, we could also have a Petri-net or a BPMN model that can synchronize with us. The only thing that we need is that it has a label transition system and a notion of included exclusion events. In order to synchronize this, we have a notion of links. These links can be regular actions or limited actions. Regular action is the real action, the real decision that has to be taken care of. On the other hand, we have the limited actions. This in some deontic logics is called the count as conditionals. Allows us to describe an event that cannot be taken in isolation, but it depends on the execution of a regular action, a regular event, for this to be considered to be executed. So going back to the reference example. So we still have the decisions, and we have these paragraphs that influence these decisions. Well, the simplest thing is to consider each of these paragraphs in isolation. So we have 4 different process models here, and we have different ways to relate them. So going back to paragraph 48, we see that there is a interaction between the paragraph 48 and the paragraph 50. Now, the paragraph 50 and the paragraph 48 only have one relation to each other, so there is no more interactions, which means that we could actually do substitution between event substitution and merge these 2 graphs together. That works well for one-to-one relations, for one-to-one links. But on the other hand, going back to the decision that we have in the first line, well, this decision is influenced by different paragraphs, and that needs to be reflected into our development. Now, a substitution is not really possible here, because when we see the graphs, it is not really the same the information that is given, the semantics that is given to each of these events. For instance, in paragraph 63, we describe an event, the decision describes an event for performing a children examination, while in paragraph 58, the decision describes the power from the municipality to remove a child from the home. So instead of doing renaming, which would be adverse to our needs, we have the notion of links. And in this case, the notion of links allows that the taking of the decision in paragraph 48, it is replicated, it is sent to paragraph 48 and paragraph 63. Formally, we have the description on paper. How would you do the projection from for the communication from the site to examination? One of the questions that we have when approaching the formal models of law was to look at how different models relate to each other. And for this, we explored the notions of process refinement. In particular, process refinement is defined as language inclusion in TCR graphs, and we leave this into to networks. This means that when we want to relate an abstract network and an implemented or refined network, we would like to see that all the behaviors, all the traces, all the accepted traces that exist in the general network are still preserved by the set of traces, resulting in a network that has links. Now, this in general is a computationally expensive process. This is an NP-hard problem, because language inclusion is an NP-hard problem in these aircrafts. But we can, in part of the results in the paper, that was to come up with a syntactic restriction with a set of processes that can be efficiently statically look, that can preserve refinement. The development of this paper has been formalized using the Isabel theorem prover, and a partial implementation of the network mechanism has been made available by the industrial partner DCR Solutions. They are using this to provide support for networks for the municipality subtiers that are currently using modular versions of processes and in the implementation of the case management system. For this paper, we perform a qualitative evaluation of networks by interviewing one caseworker in the municipality, to which we apply grounded theory to define limitations and advantages of the formalization. Part of the outcomes of the qualitative evaluation confirm that networks extends the modeling capabilities of these aircrafts and allow caseworkers to describe laws in a modular fashion, which at the same time facilitates the modeling capabilities and the maintenance and verification in isolation. However, there's also some room for improvement. At the moment, only the formal engine implement networks, which means that most of the cases needs to be tested already at the implementation phase. So one possibility would be to extend the work with modeling and simulation capabilities. Also, when it comes to sharing data between different graphs. To conclude, in this paper we look at a theoretical and practical approach to compliance by design. Most of the challenges here were given by real problems in law, and by real clients in municipalities in Denmark. That already brought a set of theoretical questions. In this case, the notion of what is a link and what is a reference in a law, and how can we capture the semantics of law. But it also brought different software products, in this case an engine and a case management system that supports such an engine. This at the end was tested, and it's a very interesting way of approaching both the theoretical and also the practical development of a case management and information systems. Thank you very much. It's been a great pleasure, and I'm hoping to see you at IFM 2020.